Hey, it's Mr. Estrada here. Our learning target says I can find the volume of prisms. So let's begin. A prism, you're probably wondering what a prism is. So let me tell you, a prism is a three-dimensional figure whose bases are congruent and parallel. So let me go ahead and just show you a prism, and I'll show you a cylinder. So here is the base of a cylinder. Here's the other base. So the bases are congruent and they are parallel, and then I could just connect them and I get my cylinder there. So a cylinder is a type of prism. So a prism is just a three-dimensional figure whose bases are congruent and parallel. So the bases are congruent, same circle, and they're parallel to each other. We also have what is called a triangular prism. So it's just basically the bases are triangles and you get a three-dimensional shape from it. So that's your triangular prism. We also have a rectangular prism. Rectangular prism, and that's basically, right, you're going to have a rectangle for a base. Try to make them both congruent. All right, just those are congruent bases, right? That's the definition of a prism, and you make it a three-dimensional figure, and that's what a prism is. All right, so a prism is a three-dimensional figure whose bases are congruent and parallel. All right, now, another way you could think of a prism is a stack of two-dimensional figures. So let's take the cylinder, for example. A cylinder is really a stack of circles. So let's look at these pancakes here. So take one pancake, it's a two-dimensional figure. But then you take a stack of them, you get a three-dimensional figure, which is a cylinder. Or you could also do the same with CDs, right? You have one CD is a two-dimensional figure, but then you stack them all up, you get your three-dimensional figure. So you could also think of a prism as a stack of two-dimensional figures, all right? And from that way of thinking, we get the formula for volume. So write this formula down. This is important. The general formula for the volume of a prism is V equals the area of the base times the height. This capital B stands for area of the base. So that's how you get the volume. You just take the area of the base and you multiply it by the height. Okay, let's look at our first example. It says find the volume of the cylinder. Not drawn to scale, round to the nearest tenth. So the base is a circle. Base is a circle, which means the area of the base is equal to pi r squared. That's how you get the area of a circle. So let's keep that in mind. All right, now let's find the volume. So the volume is the area of the base times the height. So the formula for volume is pi r squared times the height, which makes sense if you think about it, right? Because you got to find the area of one of the circles. So let's say this yellow region is the area of one of the circles. But you want to know the total space this takes up, so you have to multiply it by the height. So that's why this formula makes sense. Remember I told you that the cylinder is a stack of circles. That's why you're multiplying by the height. Okay, going back to this problem. So you substitute, and you're going to get this, because the radius is equal to 5 inches and the height is equal to 9 inches. So we put 5 in here for the radius and we put 9 in here for the height. Do a little simplification. We're going to get 5 squared, 25. Inches squared, inches squared. Bring down the pi, bring down the 9 inches. 9 times 25 is 225. And now inches squared times inches is going to give us inches to the third power. And then just bring down the pi. Just a little side note, okay? Whenever you solve for volume, the units, in this case the units is inches, the units should be raised to the third power, all right? Okay, so for this problem, it says to round to the nearest 10, so we're actually going to have to multiply this out. So we're going to have 225 times pi, and that gives us 706.9 inches cubed when you round it to the nearest 10. You can't leave your answer in terms of pi because it says round to the nearest 10. Okay, example 2. A packing carton in the shape of a triangular prism is shown in the diagram below. What is the volume in cubic inches of this carton? So the formula says area of the base times the height. Well, the base is a triangle. See that? The triangle is the base, not this rectangular part. Because remember, the bases are parallel to each other. That's how you know that the base is the triangle. Because the bases are supposed to be parallel in a prism. So the area of the base, so capital B, area of the base, is equal to base times the height of the triangle, but I'm not going to call it height, I'm going to call it altitude. Because I don't want you to confuse it with the other height. So it's the area of the base. Remember, this capital B stands for area of the base is equal to the base times the height. Excuse me, the altitude, right? I'm using the word altitude for the height of the triangle. So then our formula is really this, right? Volume equals the base times the altitude of the triangle divided by 2 times the height of the prism. So we substitute, we get 6 times 4, right? The base is 6, the altitude is 4, divided by 2 times 10. Simplify a bit, we get that. Simplify some more, we get 24 over 2, that's 12. 12 times 10 is 120. So our answer is 120 cubic inches, or inches cubed, and it's choice 3. Example 3. A rectangular prism has a base with a length of 25, a width of 9, and a height of 12. A second prism has a square base with a side of 15. If the volumes of the two prisms are equal, what is the height of the second prism? So we have a rectangular prism and we have a square prism. So you know the formula is basically the area of the base times the height for both. For all prisms, the formula is the area of the base times the height. Remember that capital B stands for area of the base. Well, how do you find the area of a rectangle? Well, that's going to be length times width. That gives you the area of the base, and then you got to multiply that by the height. Same thing for a square. It's the same formula to get the area of the square. It's going to be length times the width times the height. So they both have the same exact formula. Okay. To solve this problem, we're going to need the volume of the rectangular prism. So let's go ahead and find it. So it's going to be V equals 25 times 9, which is 225. And then 225 times 12, that's 2,700. So the volume for the rectangular prism is 2,700. So we got the volume of the rectangular prism. Now it says a second prism has a square base, so that's right over here, the square prism. And it says the side is 15. Now look, since it's a square prism, and we know the side is 15, that means the length and the width are both 15. Right? Here, let me draw a picture for you so you could see it for yourself. Right? If it's a square prism, it's basically, you got, here, I need some space. Let me do that here. So you got a square for a base. And let me just take that one, do a copy and paste, put it here. So you basically have a prism that looks like something like this, right? This is just to help you visualize. And since we know that one of the sides is 15, we know the other side has to be 15 because this is a square. All we're trying to figure out is what the height is. That's what we're trying to figure out. So now, according to this, the square prism has the same volume as the rectangular prism. So I could take this volume, because it's the same as the volume for the other one, and I could plug it in here. So I'm going to get 2700 equals 15 times 15, which is 225. So I get 225h, and then you're just going to solve for h. So I'll continue here. So you get 2700 equals 225h. Divide both sides by 225. And we will get, what is that, 12? So the height is 12. So if the height is 12, and with this side, you'll have this volume. Okay, I hope this video helps you with volumes of prisms. I look forward to working on this topic with you tomorrow. Take care.